Toyota is preparing one of its biggest battery transformations since the original Prius, but the headline needs clarification. The company is not suddenly killing every nickel-metal hydride hybrid battery, and its 1,000-kilometer target applies to next-generation battery electric vehicles, not ordinary hybrids. From 2026 into 2027, Toyota plans to introduce several new battery types, including lower-cost lithium-ion phosphate technology, advanced bipolar lithium-ion batteries, and potentially from 2027 to 2028, its first solid-state battery EVs. These developments promise longer driving range, faster charging, and lower production costs. But some remain targets rather than guaranteed real-world results. So, which technology is arriving first, which Toyota models could receive it, and what does this mean for future RAV4 and Prius owners? Let's break down what Toyota has actually confirmed. Toyota has revealed a major upgrade to its hybrid battery strategy, but it is not abandoning nickel-metal hydride technology overnight. During its fiscal year 2027 first-quarter presentation, Chief Accounting Officer Takanori Azuma confirmed that Toyota will begin converting selected Japanese production lines to manufacture next-generation hybrid batteries. The transition is expected to accelerate through 2027 and 2028, creating enough annual capacity for approximately 600,000 vehicles. Toyota has not yet disclosed the battery's chemistry, capacity, or energy density, although reports indicate a greater shift toward advanced lithium-ion technology. The company says its objectives are improved performance and stronger cost competitiveness. This investment comes as Toyota expects global hybrid demand to exceed 5 million vehicles during fiscal 2027. However, these batteries are primarily intended for hybrids, not 1,000-kilometer electric vehicles or Toyota's future solid-state models. Those belong to separate battery development programs. Toyota is also strengthening production outside Japan. Its Indonesian subsidiary has partnered with CATL to expand from assembling hybrid battery packs toward locally manufacturing cells and modules. Toyota has invested approximately 1.3 trillion Indonesian rupiah, around 76 million US dollars, with battery and component exports scheduled to begin during the second half of 2026. CATL is separately participating in a much larger Indonesian battery ecosystem, initially targeting approximately 6.9 gigawatt-hours of annual capacity. However, that entire multi-billion-dollar project should not be described as a Toyota-owned facility. This is less about Toyota suddenly becoming an all-electric manufacturer, and more about building a broader battery supply chain capable of supporting hybrids today and increasingly competitive electric vehicles tomorrow. Toyota is not simply changing battery chemistry, it is developing a broader battery supply chain across Japan, Indonesia, and China while preparing several different technologies for hybrids and fully electric vehicles. Toyota's next-generation performance lithium-ion battery is being developed for electric vehicles expected from 2026 onward. Combined with improved aerodynamics and reduced vehicle weight, Toyota originally targeted approximately 1,000 kilometers, about 620 miles, of range under its stated test assumptions. The company also targeted a 20% cost reduction compared with the original BZ4X battery and a 10 to 80% rapid charging time of 20 minutes or less. However, these remain development targets, not guaranteed real-world figures. Actual range will depend on vehicle size, weight, weather, wheels, and the testing standard used. Toyota is also developing a high-performance bipolar lithium-ion battery, with a high nickel cathode for possible introduction during 2027 or 2028. Toyota projected approximately 10% more range than its performance battery, potentially around 1,100 kilometers, while targeting charging in 20 minutes or less. Importantly, Toyota described its cost target as roughly 10% below the original BZ4X, not an additional 10% reduction beyond the performance battery. This is also separate from Toyota's solid-state program. Bipolar construction allows adjacent cells to share current collector structures, creating a more compact internal design with fewer connecting components. That can support higher power output and improved packaging, although it does not automatically make the entire vehicle 35% more energy dense. Toyota's ambition is clear, but until production vehicles arrive, the range, charging, and cost numbers should be treated as engineering targets, not confirmed customer specifications. Bipolar battery construction could reduce the number of connecting components, saving internal space and supporting higher output. Toyota has already used bipolar battery designs in hybrid vehicles such as the Aqua and Crown, and it now plans to adapt the concept for fully electric cars. One proposed version combines bipolar construction with lithium-ion phosphate, or LFP, chemistry. Compared with the original BZ4X battery, Toyota has targeted a 40% battery cost reduction, approximately 20% more driving range, and a 10 to 80% charging time of 30 minutes or less. However, this does not mean an entire Toyota EV will become 40% cheaper. Batteries are only one part of a vehicle's total cost, and Toyota has not confirmed future retail prices. The technology could help Toyota compete more effectively with lower-cost Chinese manufacturers such as BYD, but price parity is not guaranteed. Toyota is also developing gigacasting integrated vehicle structures and self-propelled assembly lines. The goal is to reduce component counts, production processes, investment requirements, and manufacturing lead times. Together, these technologies could make Toyota a much stronger EV competitor. Beyond conventional lithium-ion batteries, Toyota continues developing all-solid-state technology. The company is targeting an initial market introduction during 2027 or 2028, with approximately 20% more range than its planned 1,000-kilometer performance battery and charging from 10% to 80% in 10 minutes or less. These figures remain development targets, while early production could be limited. Toyota's previous claim that battery EVs might reach only around 30% of the global market reflected Chairman Akio Toyoda's prediction, not an official admission that Toyota was abandoning EVs. The company still promotes a multi-pathway strategy combining hybrids, plug-in hybrids, EVs, and hydrogen vehicles. Toyota's EV sales are now rising quickly from a relatively small base, but hybrids remain the overwhelming majority of its electrified vehicle business. Toyota has increased its fiscal year 2027 vehicle sales forecast to 9.7 million units, driven partly by continued hybrid demand across North America and Europe. That successful hybrid business gives the company the revenue, production scale, and supplier network needed to support its next phase of battery development. But producing lithium-ion batteries for hybrids does not mean those factories can immediately manufacture large EV battery packs. The real advantage is the knowledge Toyota gains in battery chemistry, quality control, sourcing, and high-volume production. Toyota's future electric vehicle roadmap includes development targets of approximately 1,000 kilometers of range, faster charging, and lower battery costs. However, impressive laboratory targets will only matter if Toyota can mass-produce the technology reliably and install it in electric vehicles that customers can afford. The competition will not stand still. BYD, CATL, and other Chinese companies continue expanding production while reducing prices and improving battery performance. Toyota may be positioning itself for a carefully timed comeback, but 2027 and 2028 could determine whether that patience becomes a competitive advantage or leaves the company chasing faster-moving rivals. So, is Toyota's strategy finally about to pay off, or has it waited too long?